So that's level one. Level two is thinking about this kind of question. What proportion of customers would receive bags weighing at least 990 grams? Okay, so again, from a sales perspective, I think the importance here is if I'm selling a 1 kilogram bag of popcorn, of course, nobody's going to be insane enough to go, measure all their popcorn. But, a customer should be reasonably sure that they're going to get 1,000 grams. And so we're asking how many are going to receive at least 990 grams. And the picture has something to say about that. Because basically, everybody on the right side of this line is going to satisfy that bigger than 990 aspect. And the question is, what percent of the population am I talking about? So here there's another conceptual switch where we were talking about histograms and individual bars, and then all of a sudden we're going to kind of switch to thinking about visually if the whole curve represents the whole population, everybody, all the bags of popcorn, all the babies, whatever, then how do we kind of think about this in terms of proportions? Like what proportion is on this side of the line, what proportion is on this side of the line, okay? So I kind of want to get my little drawing pad out because there's going to be better drawings for you. All right, give me a second, or let's take a 5-minute break. I'm going to get myself set up with my little drawing situation. You need to get some water or go to the bathroom, do that, and then I'm going to pick it up with my pen. Okay, so here's my bad drawings with my finger. Okay, if this whole thing represents 100% and I draw a line here, what percent is on the right and what percent is on the left? Now, I can use some kind of visual estimation to come up with an idea. For instance, I know that if I draw the line exactly in the middle, this side is 50% and the other side is 50%. But if I draw it to the left of that, then this side must be more than 50%. So I don't know, maybe 60%, maybe 70%, right? It's a little hard to tell. I'm just kind of picking a number out of thin air that's bigger than 50% and smaller than 100%. This is where the normal distribution comes in. We've got a picture that can help us, and then we're going to use a tool called the Z-score. Okay, so that's conceptually, we're shifting from talking about individual bars to talking about kind of a picture in our mind of a normal distribution, which is just this curve, okay, where it's symmetrical, the center is the mean, the median, and the mode. This side is 50%, this side is 50%. Okay, now let's go back to this picture. Oh, wait, I want to just share up everything. Okay. So their question was, what percentage would be more than 990, right? Now, this is where this diagram in the book is helpful, because what they do in this picture is they break up the normal distribution into 8 little compartments. Now, these numbers all based on the empirical rule, which is the 68%, the 95%, and the 99.7%. Because if you look at the two numbers in the middle, what do they add up to?
68.
68%, right? So that's the idea that it's symmetrical. We're splitting it in half, so 34% on this side and 34% on this side. Where does the 13.5% come from? Well, if you add up everything in the middle, in those middle 4 boxes, you will find that you get 95%. So mathematically, we can work it out and say, well, we got 95%, and then we take out the middle 68%, then what's left is 27%, and then we take the 27% divided by 2. You don't have to do all that math. It's done for you in this picture. And this is only a rudimentary way to get started. Basically, if I draw a line, where's my annotation here? If I draw a line here, I can use this concept to say, well, I've got 13.5%, I've got 34%, I've got another 34%, I got another 13.5%, I got 2.35%, and I've got 0.15%. So I'm going to add all those up, and that's going to be what percent is on the right side of that line. That's what's happening with the question about the 990 grams. They're basically saying, well, if you draw the line there, then everything to the right would add up to whatever it adds up to. You guys want to add it up? See what you get? There's another way to solve the problem, which is a little shorter, but if you want to think about that, you can. If you want to just add them up, you can. Okay, what do they add up to?
97.5.
97.5%, correct. Now, did anybody figure out a faster way to do that other than adding all those numbers up?
Subtract the bottom 2 and divide by 100. Subtract by 100.
Yeah, because remember, all of this needs to add up to 100%. And so if this part, we just take it away, then we figure out what's left. And that's kind of a faster way to think about it. There's some application there when we're going to get to the z-scores. But if you're just using this picture, you can do it either way, and you get 97.5%. So that's how I would answer the question that they asked about the 990, which is that because the line 990 is 2 standard deviations, and if I draw that line and then I look at everything to the right, I should come up with about 97.5% of the bags of popcorn are bigger than 990 grams. Now, where we're headed is that if we don't end up on a specific line, we still want to be able to answer the same question. What percentage of customers would get bags less than a kilogram? That's really an important question, because that's the number of people who could buy your product and then say, oh, no, you didn't give me what I paid for, and I demand a refund or a new bag or whatever. And so you would want to know, if you're manufacturing, what percentage of the customers could possibly have that experience. We know that from the standard deviation, I mean, sort of the normal distribution, most people are going to get stuff that's in the middle of the curve. And I've set the average to be slightly higher than 1,000, so that, you know, most people are going to get between, let's go back and look at our picture. Most people are going to get, 68% of people are going to get between 1,015 and 1,065 grams. So it shouldn't be any problem. The problem is this line that I'm drawing here, 1,000 is not on my graph. And so I got to think about, how do I figure out what's the quantity, what's the proportion of people that are going to have that experience. If I draw the line at 1,000 here, because that's what I'm telling people these bags are full of, I'm going to have a certain proportion of people who are to the right, but I'm going to have a certain proportion of people who are to the left. And this is the question I want to be able to answer. What proportion of people would get less than 1,000 grams of popcorn? So let me show you the approach for that. Got it written out here. Gotta clear my drawings. Okay, so this is the z-score process. I'll give you a minute to write down the notes. There's a formula for the z-score. It's on the formula sheet. So that's the first thing we're going to do. Then we're going to convert that to a probability percent, and I'll show you how to do that. That's on the formula sheet. And then the last part is really where all the hard work is, where you interpret the sentence So again, in terms of that cheeseburger of quantitative reasoning, the math is happening in number one, and then the rest of it is all kind of interpretation. And that's in many ways the difficult part of it. Let's look at this. We're going to stick with the same problem. We got 1,040 grams is the mean. 25 grams is the standard deviation. Question: what percentage of people are going to get bags that are less than 1,000 grams? Okay. Now they threw in a little wrinkle there with the 1 kilogram, 1,000 grams, but we'll just skip over that part. That's an application of conversions. That's what I meant by you see conversions show up in this section. It's really kind of incidental. Okay, so first thing we do is get the z-score. Now, if you look at your formula sheet, you'll find on the back a place where it says z equals. And so that's what I want to show you here. The problem is that it's all written in symbols, so you need to interpret it. Of course, in your book, the formula is actually given to you with words. You take the value, you subtract the mean, and you divide by the standard deviation. What I would say is, generally, it's easy to pick out the mean and the standard deviation because those numbers will be next to words like average and standard deviation. And so you'd be able to say, oh, this is the average, this is standard deviation. So those are the two numbers that I would go for first. In this problem, you can see that the mean, the average, is 1,040, and the standard deviation is 25. So the question is, what the heck is this third number? Where is that coming from? Because that just says value in the formula. So what do you think? What's that third number?
Is it the 1,000?
Correct.
Right.
Because it's what we're trying to find the z-score of. And the z-score of 1,000 is going to lead us to the answer to this question. In words, and again, if you're taking statistics class, it would be more important to really understand all of this and appreciate it. But basically, the z-score is a measure of how many standard deviations away something is from the center. So it's kind of like a measure of strangeness, because the further away you are from the center, the more unlike the average you are, which is weird. I mean, we expect most people to be near the center, near the average. Okay, so what do you get when you do that calculation? This is kind of like the relative change, because you've got to subtract and then divide.
Z equals 1.6 grams.
Negative 1 point.
Okay, so first of all, yep, it's negative. And you can see that because the first number minus the second number is going to give you a negative number. We're taking 1,000 and we're subtracting 1,040. So it's really like the second time in the course where negatives come into play, because it says something important about the situation. In this, it says we're less than the mean. If you get a negative z-score, you're lower than the mean. So yes, it's negative. And number two, there's no units on this because grams divided by grams would cancel each other out. And so it's not grams. The z-score is not in terms of grams. It's just a number, which is, again, measuring how many standard deviations away from the center we are. So now we take that number. That's step one. Step two, we convert it probability or percent. So to do that, we go to our formula sheet, and I'm going to go to the one that's in the book here, but you can use your yellow sheet too. And this is looks like a complicated table with a lot of numbers, but basically there's 4 columns, and they would have put it all together in one big column, but it would have taken up 4 sheets of paper. So they just put the columns next to each other. On the left side, you have the z-score. On the right side, you have the probability. So that's what I mean by convert. You need to find that z-score, and you need to take it to its probability number. So did you find it?
Yeah. 0.0548.
Good. So that's z equals negative 1.6 is being converted into, I'm using an arrow, not an equal sign, 0.0548. And as a percentage, I would say that's 5.48% or 5.5% if I don't want to be so fancy. Okay. Same issues about rounding that are always there in the background. Right? How many decimals do we report? What's happening? Again, from my perspective, saying too many decimals just confuses what we're talking about. And so the third step in the notes was to interpret it. And I said, this is a little complicated. I can't give you specific instructions about when it's going to be this, when it's going to be that. Yeah, I wish I could say every time you see the word more, it's like this, and every time you see the word less, it's like that. But reality, you have to kind of think about what we're asking here. I want to know who's getting less than 1,000 grams. If we go back to the picture and we think about whether that's a minority part or a majority part, it should be clear that it's a minority part. And therefore, this is the right answer. We expect 5.5% of customers or bags to have less than 1,000 grams. So we're making a sentence like that out of the z-score. Because that number 1,000 did not land on any of our special z-score numbers, and therefore we couldn't really use the drawing. I mean, we could have kind of estimated, but it's hard, especially when we're in the middle. The curve really dramatically affects things in a way that sometimes people get very wrong. So we have this z-score technique to do the work for us. So again, you've got three numbers. My recommendation is that you should be easily able to pick out which one's the average, which one's the standard deviation, and those help you set up your z-score formula. That's step one. Step two, you got to use the table, go make the conversion. And step three, you're trying to answer the question. So let's get up to step three, and then we'll talk again about how do I interpret this. Well, let's, since nobody's jumping out there, let's just work on how we would calculate the z-score. Something minus something divided by something. Okay, what numbers were you able to put in place?
168.
Okay, 168 goes here. That's good.
The 160 first, 160 minus 168.
Good.
And divided by 12.
Good. That's it. So that ends up being negative, first of all, I noticed because I'm taking a 160 minus 168. Okay, so that's my z-score. A lot of times there's a question on the test that just asks for the z-score. That's all you have to do. There's no interpretation, nothing, right? The harder question is, what do you do with it and how do you make sense out of what that is? So what's the probability of finding someone who's less than 160 centimeters? Now we're getting into step two, step three. Now, one of the hard things about this question as compared to the last question is that z-score is not in this table. So what are you going to do?
Just use it?
I mean, what z-score are we going to use here? Because minus 0.666666 is not in my table.
Around it.
Yes,
That's what I was thinking.
This is kind of where you should be looking. What's your best choice?
-7.
70?
That's a hard question. This is closer. If you think about the difference between 65 cents and 66 cents and 70 cents, 65 is closer than 70, right?
Okay.
I know the standard rounding rules, 66 would go up to 70, right? But if we have a choice of 65, that's better. That's a minor error, but I just wanted to bring that up in case that comes up in the test. So then what do I do with this number? That's the next part. 0.2578 is what I get to. And how do I use that to interpret? C equals minus 0.666. That leads to 0.2578. And what do I do with that?
You turn the 0.2578 into a percentage.
Okay, so that's 25.78%, which is about 26%. And am I saying 26% is the answer? 26. So then I just kind of take my sentence, my question, and I turn it into a sentence. 26% of people, guys, are less than 160 centimeters tall. Or there is a 26% chance, and this is where we're headed on Wednesday, talking about probability. And the question is, do I want that minority part or do I want the majority part? Now, let's just do some quick practice examples. If I have 26% over on this side, what's the percentage over on the other side? Just draw a little picture here. Here's my bell curve. I drew a line. If this side is 26%, then what's over here? 74%. Good. So it's really just the complement, the thing that would need to add up with it to make 100%. Do I want the 74% in this case, or do I want the 26%?
You want the 26%?
Right, because I'm looking for someone who's less than 160 centimeters. If I was looking for somebody who's more than 160 centimeters, I would say 74% of guys are more than 160 centimeters. Okay, let's do another one. Okay, this is a sample type of question. Give you some time to work through that.
V equals 15,000 miles.
So the 15,000 is not going to go there because that's 15,000 is a standard deviation. You mean 150,000?
Yes, sorry about that. Minus the 120K. Divided by the 15,000. That's what I
So if my calculations are correct, that should be equal to 2.
yeah.
Is this going to be 30,000 divided by 15,000, and that's 2. So Z equals 2.
Mm-hmm.
From there, we're going to take it to its probability number. So we need the table for that. There's no rounding in this one. 0.9772.
Mm-hmm.
We can turn that into a percent. So it's about 97.7%, 98%, something like that. And so now we're at the last step, interpret. 97.7% chance that my Kia Rio is going to last more than that. Are we looking for the minority part or the majority part? So let me use the picture to try to help you think about that. Here's the curve. We're drawing a line that's up here, right? How do I know it's up there? Well, I know that 120,000 is in the middle, right? So I don't have to draw the whole thing out. I can just kind of do some thinking about where the center is and where I'm drawing my line. My line is on 150,000. So I'm drawing it up here. And I want cars that last longer than that or not as long as that. Well, I want my car to last long,
Longer.
Longer.
and that's the minority part up here. Right? Longer, taller, heavier, bigger, that's to the right. And that's the minority part, which means this answer is not right. We've got to do the 100% minus 97.7% to get the answer. So 2.3% is the correct answer there. And that last part requires some critical thinking about the context, the picture, the shape, what's happening. Do I want the right side or the left side? All of the numbers in the table are the left side numbers, the less than numbers. So I would say there is a 2.3% chance my Kia Rio will last that long. That's not a great chance, but it's possible.
So when we're dealing with minority, we're always gonna subtract about 100.
No, it's not that easy.
Okay.
Because we talked about the minority parts in the last couple of problems and we didn't have to subtract it from 100.
Right.
So what I'm suggesting is when you get to that finish line and you're thinking about whether you have the right answer or not, think about whether you have the majority or the minority piece. The minority piece has to be less than 50%. The majority piece has to be more than 50%. So if your piece is a minority and your answer is larger than 50%, then you got the wrong side. If your piece is the minority piece and your answer is less than 50%, that's good.